Welcome to Zebra Aurora Vision Studio. In this tutorial, we'll learn how to perform a simple saw blade inspection using a couple of different tools useful in many machine vision projects. To complete our task, we will need DetectCircles filter, available in the filter library under Hue Transform, Create Circle Path filter, which can be found in the Path category in the filter library, as well as ScanStripes filter, available both in the filter library and the toolbox. If you are not familiar with the filter library or the filter search tool, please check our other tutorials. You can find links in the video description below. In this tutorial, we will be working on a single image. Let's load it from our hard drive. To do that, we'll use the Load Image filter available under Load Files tool. We can select the file either by double-clicking the In-File input on the filter block or by clicking the triple dot icon in the Filter Properties window. Let's preview our image by dragging the InImage output into the Preview window. Next, we iterate our program once, either by pressing F6 or by clicking the Iterate icon to refresh the preview. Before we proceed, let's pause for a second and think how our algorithm should work. Our goal is to count the total number of the blade's teeth. We notice that the teeth are located evenly along the blue path, and that its center is shared with a small circle located in the center of the blade. Knowing that, we can establish the first two steps of our program. First, measuring the small circle, locating it, and obtaining the XY coordinates of its center. And second, measuring the blade's diameter and creating a circular path originating from the small circle center with diameters slightly smaller than the blades. Now, when we know exactly what to do, let's get straight to it. First, we need to measure the diameter of the small circle. For that, we'll use the Measure tool located in the toolbar. Simply click the tool, draw the line inside the preview window and read the length displayed in pixels. The diameter of the small circle is about 44 pixels, so we can assume that its radius is 22. Next, we will add the DetectCircles filter to our program. This filter is not available in the toolbox. We'll need to look it up using the search control. We can enter either a full phrase or just its part. Our search returned two results. We'll use the first filter. We'll use the single variant because we want our program to look for a single circle. Next, we provide an input image to the DetectCircles by connecting it with Load Image, and when it's done, we can start tweaking the parameters. The two parameters we need to adjust are inRadius and inROI, which is the region of interest. We know that the radius of the circle we are looking for is about 22 pixels. Let's type this value in. As for ROI, clicking the triple dot icon will bring out the ROI editor. By default, it is set to brush mode, which allows for freehand painting. We will, however, switch to elliptical region mode, just for convenience, and select a region slightly larger than the object we are looking for. Specifying the ROI basically tells our program which area it should focus on. This can speed up our program greatly compared to when it has to analyze the whole image. Let's preview the result now by dragging the OutCircle output into the preview and iterate our program once. As we can see, the filter has detected the small circle without any problems. The last thing we need for the later parts of our program is the circle center. We can obtain its coordinates and display it by activating an additional output. To do that, click the Show Hide Ports link in the middle of the filter block and select Center from the OutCircle drop-down menu. This activates an additional output, which we can now preview or use with other filters. Let's try to display the OutCircle Center output. As expected, because our program was just paused, not stopped, the point appears in the preview window in real time. The next step is creating a circle path along the blade's circumference, which we will use for scanning for the teeth and counting them later on. We need to look for a suitable filter first. We'll use our search tool again, look for creates a phrase and see what we get. The search has returned multiple results, including the create circle path filter, which is exactly what we need. Let's add it to our program. We need to create connections between DetectCircles and create circle path now. We want to use the small circle center as the center point for our circle path. Let's try to connect the filters. It seems that we cannot make the connection, everything is grayed out. To solve this problem, we need to activate some extra inputs, but let's check the properties first. There are only two properties, the inCircle structure and inPointCount. We can expand the inCircle and see what's inside. As expected, we see both the circle center with its coordinates and the radius here. To access these ports, we need to expand the inCircle structural fields. We can do that by right-clicking the input and selecting Expand Structure Fields from the drop-down menu. As we expected, it activated some extra inputs on the right side of the filter. Let's try to make the connection now. Yup, it worked like a charm. We're good to move to the next step. We want our path to intersect with the blade's teeth somewhere in the middle of their height. For that, we need to check the blade's diameter first. We'll use the measure tool for that again. The blade is slightly over 260 pixels in diameter. We can assume that the radius of our path should be somewhere around 125 pixels. Let's type this value in and drag and drop our path into the preview. We've got another problem. Our path is an octagon instead of a circle. It's not a bug though. The inPointCount, which is the number of points in the path, is equal to 8. Let's change this value to, let's say, 40. And it's fixed. As simple as that. We can now proceed to the last part of our program, which is scanning for stripes along the path and counting the blade's teeth. This time, we'll look for a necessary filter in the toolbox. We'll find it in the Computer Vision 2D section under Scan Edges 1D. This filter has a couple of different variants: Scan Edges, Ridges and Stripes. We'll use the ScanStripes multiple variant. The other ones are described in detail in our technical documentation. Let's add this filter to our program now. We notice that there are yellow question marks next to some ports. They indicate a missing connection. If we try to run our program, we'll get a warning window pop up with a list of issues. Let's make the connections now, using the image from Load Image and the previously created circular path. This ScanStripes filter has quite a few parameters. We won't be discussing them in detail here, but we highly encourage you to check this filter's documentation as well as our machine vision guide. It's good to understand the polarity parameter though. Dark indicates that the algorithm will look for dark pixels on bright background, which is what we are looking for. Changing it to bright would give us the opposite result. Now it's a good time to adjust our previews a little bit. we have quite a few elements displayed in a single window. We could, of course, show everything in it, but using multiple windows is far more convenient and gives us much more freedom as well. Changing the layout is easy. We can use the layout icons in the toolbar or right-click the tab and select the split method from the drop-down menu. As for other options like undocking or adding comments, we won't be discussing them here. Let's split our preview window horizontally first and adjust its size. We can now split it again, this time vertically, to get a neat and clean preview layout. We can use the right window to preview anything, for example, the image as well as the scan stripes. This way, everything is visible and organized, which makes our life easier. The final step is checking the teeth count. Luckily, the ScanStripes filter already did all the heavy lifting for us, and to obtain this result, we just need to activate an extra output. We can do it either by clicking Show Hide Ports, or by right-clicking an output and selecting what we need from the Property Outputs menu. Let's choose the outstripes and activate the count value. We can then drag and drop the new output into the bottom preview window, which displays the data in textual mode. This concludes our tutorial. As always, we encourage you to check this and other tutorials and examples available in our technical documentation. If you want to learn more, please take a look at our technical documentation available at Zebra Aurora Vision Developer Portal. You can find links to the sections of the documentation relevant to this tutorial in the video description below. Thank you for watching. For more information on Zebra Aurora Vision software products, visit us at aurora-vision.zebra.com.